Okay, so this is over chapter 2, section 2, polynomials of higher degree. And what that means is you're going to have x usually to a power definitely higher than 1, but usually higher than 2 also. And these are your problems, page 133, 19, 27 odd, 33 to 51 odd. And this is going to be due for the people on Monday. It'll be due on Wednesday. And the people on Tuesday will be due on Thursday. And again, we have our next test on 9th, September 30th, October 1st. So I'm going to look at this real quick. We are supposed to be using a leading coefficient test to find out end behavior. So the chart on the next 2 slides are actually something you need to memorize. And we're going to be finding the real zeros, or what's also known as the x-intercepts of functions. And we're going to use some stuff that we've done before. And then repeated zeros. If you have a factor, x minus a, and it's done more than once. In other words, k is greater than 1, so maybe it's done 2, 3, 4 times. X equal a has a multiplicity of however many times that factor works, and I'll hopefully show you one of those in a minute. If k is an odd number, then it's going to cross the x-axis at this a value, which is a 0. And if k is an even function, it is not going to cross the x-axis. It's going to just touch it at x equals that a, and it might be a maximum or minimum on that graph, and we're going to talk about that in a little while. So here's the chart you need to know. So every polynomial function is written like this thing up here at the top, and the only thing that we need to know about end behavior, the only part that will tell us everything we need to know is this part right here. That is this thing's called the leading coefficient. And this is your biggest exponent, n. We want that to be the biggest exponent. So if you look right here, if you distribute this, the leading coefficient is 7/8 s cubed. So the two things we need to realize is that this thing right here is a positive number, and this thing right here is an odd power. So we want to know what happens at the ends. As I go to negative infinity and positive infinity, what happens? So if I have a positive leading number, that's this side. If this would have been a negative number, I'd use this chart. And I have an odd power, so that means I'm using these two things right here. So the way I write this answer is as x approaches negative infinity, that's this part right here, x is approaching negative infinity, then y is approaching negative infinity because of these two go together. This is the y value. And the other answer I have is this, and this means going negative infinity for x means going left. So as you're going left, this graph is going down. And then as x goes to positive infinity, in other words, as the graph goes to the right, y is going to positive infinity. So I'm putting these two things down as my answer. So this is the end behavior that I'm looking at. I made another chart here that you can look at, and the parts in blue are the answers, and I made it a little differently, but it's the same problem. So if I look at this real quick, now I made this a negative, so I may have screwed up on the last problem. If this is negative 7/8 in the book, it's going to change the answer. So I'm going to use this chart to do the same thing. So again, the leading coefficient is negative 7/8, and I'm still s cubed. So now the leading is negative, okay, negative, which is this one, and I have an odd power negative. So I'm going to be using this row right here. So that's going to change everything. That's going to be as x approaches negative infinity, y approaches infinity, and as x approaches positive infinity, I'm going right over here to this one, y approaches negative infinity. Now, if you notice, these two y's flip-flop, and this has to do with from the one I did before. This has to do with transformations. You remember if you have a negative, it reflects over the x-axis. So it flipped that last graph upside down. Okay, and I'm going to go to the next part. Now, this part is wanting us to use a calculator to find end behavior. So I'm going to use the chart first, and I'm going to show you how it works on a calculator. So now I have a positive and an even power. So positive even power, if you look at the chart, and I have it memorized so I don't have to go back, as x goes left, y goes up. And then as this one is, as x goes left, I'm sorry, right. I want to go to the right for x, not left. So I go to positive infinity, y goes up as well. And so over here, they're just saying, hey, you just look at the first thing. Now, this has a positive, this has an odd. So positive, odd. Now that changes the way the graph looks. So now as x goes to the left, and again, I have the chart memorized, as I go left, y is going to go down because of the odd power. And then as I go to the right, y is going to go to positive infinity. So I'm supposed to show you this on a calculator. And I kind of messed up because I should have plugged those two equations into my calculator. So I'm going to plug those in, and then I'm going to show them to you here in a second. So I got y, and I'm going to do sub 1 is going to be 3x squared. Oops. Squared. No, that's not squared yet. I got 3x squared minus 9x plus 1. And if you look, this says it's going to be in blue. Let me zoom in so you can see it better. And then the other graph is just 3x cubed. So let's enter that and put in here 3x to the third power. So the first one's blue, the second one's green, and I'm going to graph it. So here comes my first graph. So if you remember, as x goes left, y goes up. So as I'm going to the left, y goes up. As I go to the right, y goes up as well. Now this one is the cubic one. So as x goes left, y is going down, and as x goes right, y is going up. So that's showing you that those answers I had are the correct answers. And we're going to go on from here and see what's next. I think we only got one more thing to do, and we're going to find the zeros of these. So we need to factor. So the zeros are another way to say x-intercept. So when we do an x-intercept, that means y is 0, just like it did on the first test. That is not going to change, and that's going to be something you need to know every year. So when you do these kind of problems, you want to factor. So if I look at all these numbers, they all have a common factor of 3x. So I need to take 3x out to the front, which means I'm dividing 3x out of each of these. So that's going to leave me x squared minus 4x plus 3. And then I have to factor the quadratic that's in parentheses here, this part. And this factors to x plus 4 and x minus 1. Now, if you don't remember where those two factors come from, it's this. You do a t-chart, and you take 1 times 3, and you get a 3 here, and you get a negative 4. And you are looking for wait a second. I'm glad I did this because I made a mistake right here. This should have been minus 3, sorry. I'm glad I did that because a negative 1 and a negative 3 give me negative 4. So those are the two numbers that go in with the x. And then once I get here, I take all of these factors and set them equal to 0. Now, if you ever factor just a number out to the front, you don't have to worry about just a number. But since it has an x in it, you must put this all of these equal to 0. So this has 3 x-intercepts. It intercepts the x-axis is 0, 1, and 3. Now this one has 4 terms. So when you have 4 terms, you're supposed to group them in pairs. So you take the first 2, and you group the first 2, and then you take the last 2, and you group them. And you want to put them in descending order of power. These are already going 3, 2, 1, 0. And then you factor out the GCF of these two. So that's x squared, and that leaves me x minus 4. And then the greatest factor of these two, since there's a negative there, I must take a negative out with the 25, because 25 goes into both of these, and that's x minus 4. The part in parentheses must be identical every time. So you see, I hope you see those are identical. They must be, or you can't do it this way. And we are supposed to set this equal to 0. Guess I could have put it over here, it doesn't matter. And now I get to factor x minus 4 out to the front, and I have x squared minus 25. Well, x squared minus 25 is still a difference of two squares, so I can factor it more. So this stays x minus 4, and then the difference of squares factors to conjugates, x plus 5 and x minus 5. And then I take all of these factors and set them individually equal to 0, and I solve each one. So I get x equals 4, x equals negative 5, and x equals 5. And those are the zeros. Now, there are not always 3, but whatever your biggest power is up here at the top should tell you how many zeros you're going to end up with. I will talk to you next time. Have a good rest of the day.